Welcome to GetXAML. We'll solve few concepts on the problems of vector spaces, subspaces, linear independence, span, basis, and all those things. So let's begin. Let u and b be the two vectors. They are given. The angle theta between u and v is, so how will we calculate theta? It is nothing but given by cos theta is equal to dot product of uv divided by length of u into v, length of v. Now first find the dot product. Q dot v is equal to multiply each elements and add them in the columns of both the vectors. It is 1 into 1 plus 6 root 3 by 5 plus 2 into 2 minus, it is 4 minus 6 root 3 divided by 5 plus 4. This is UV. We simplify, we'll get it as 9. Next, you find out the length of u. Length of u is equal to square root of 1 square plus 2 square plus 2 square, that is square root of 9 is equal to 3. Now length of v is equal to square root of 1 plus 6 root 3 by 5 whole square plus 2 minus 3 root 3 by 5 whole square plus 2 square. This is a plus b whole square, that is a square plus b square 36 to 3 by 5 plus 2 into 612 AB, that is root 3 by 5 plus 4 plus 9 into 3 by 5 minus 2AB, 2 into 2 4 minus 12 root 3 by 5, then plus 4. So this get cancelled. Is 9, 1 square plus 4 is 9 plus 36 into 3 by 5 plus 9 into 3 by 5. So this is 9 plus 45 into 3 by 5. So 5 1s are 5, 9s are 27 plus 9, 36. So this is 36, and then square root of this. Square root of 36 is 6. So cos theta is equal to 9 divided by 3 into 6. So 1 by 2. So theta is equal to cos inverse 1 by 2, that is equal to 60 degree, right? This is the answer. Next, the cross product u cross v of this is, so cross product, how will you find? So cross product means, so you take the determinant of u cross v is equal to determinant, take 3 unit vectors. Okay. Sorry. Okay, so this is 1 0 0 0 1 0. Okay, so find the determinant of this. I into 0 minus j into 0 plus a into 1. So this is nothing but coefficients of this ijk. This is 0 comma 0 comma 1. So a is the answer. Next, if u is equal to this vector and v is given, and they are saying w equal to u plus k into v, where k is the scalar value and is perpendicular to u. So this is the case, you know, u into dot product of u into w will be equal to 0. That means what? U and V are perpendicular. The next orthogonal matrix, again we'll explain it. Okay. So what is U is given? What is W? W is U plus A into V. We can add it and perform it, but let us try to simplify here itself. So this should be 0. U into U plus A into U into V is equal to 0. Now find out U into U. It is nothing but 2 into 2 plus 1 into 1 plus 2 into 2 plus A into U into V is 2 plus 1 plus 2 is equal to 0, or 5k is equal to, this becomes minus 9. So k equal to minus 9 by 5. Next, given this vector uv, the cross product u cross v is, so they are given 4 options, so they are not asking the value here. So first find out and we'll see. I, j, k are the unit vectors. Then I have 1, 2, 3, 4, 5, 6 permanent of this. This is I into minus 3 minus j into, so this will become 6 minus 12 minus 6 plus k into 5 minus 8 minus 3. So this is u cross v is equal to minus 3, 6 and then minus 3. Okay. So now how will you find whether it's parallel to u, v, or is perpendicular? So it is not a zero vector. So you got a vector here. Let us, the 3-dimensional, right? So what is u? Vector u, where it is, say 1 is x-axis, y and z. Okay. So where is x? X equal to 1. Okay. Then y equal to 2, say somewhere here, and z equal to 3 somewhere here. So the vector is, say, somewhere here. Then 4, 5, 6. Say 4, 5 and then 6. So the vector is this one. This is u, this is v. Now what about u cross v? Minus 3. That means this angle, somewhere this side, minus 3, and then plus 6 somewhere here, same, and then minus 3 on z. So this vector, the cross product, is somewhere like this in the 3-dimensional. That means what? If you visualize like this, they are perpendicular. Okay. Parallel means it will be like this, same. So they are perpendicular to each other. Next, if u equal to 110 and v equal to 101, okay, then the magnitude of uv is, this is nothing but magnitude of uv is equal to u into length of u into length of v into sin theta. Okay. How will you find theta first? We already know cos theta equal to dot product divided by length of a into length of b. Here it is uv. Okay. So cos theta is equal to dot product is 1 plus 0 plus 0 divided by, take it as 0. Length of this is 1 plus 1 root 2 into root 2 is 1 by 2. So theta equal to 60 degree. Okay. Next. So here I got already this length, root 2 into root 2 sin 60. So this is 2 into sin 60 is root 3 divided by 2. So this will be root 3. Next, which of the following statements about the vector spaces is true? Okay, so the zero vector cannot belong to vector space. It's wrong. Zero vector has to be in the vector space. That's the axiom. The sum of two vectors in a vector space is always the vector space. Yes. According to the vector space, the condition is it is closed under addition. Addition is closed. The addition operation is closed under vector space. This is true. Multiplying a vector by scalar always gives vector outside space. No, not always. Depends on the value of the scalar. This is not true. Not always. Vector spaces can have only finite number of vectors. No, can have infinite number of vectors in a vector space. The dimension of the subspace of R power 4 defined by, see what they are saying, this is the space real by 4. So there are 4 variables, right? So 4 unknowns. You can take it as 4 unknowns, x1, 2, x3, x4. Now what is the subspace of this? Contains how many elements? That is, what is the dimension of it? So many of you think that there are 4, it is 4. No, for the space it is 4. The subspace you have to calculate. Okay, if you take this equation, already they given this equation. If you take this equation, all are trivial solution only. x1 equal to x2 equal to x3 equal to x4 equal to 0 only. That means what? One variable, say for example x4, I can write it in terms of minus x1 minus x2 minus x3, right? If I substitute it, I'll get 0 only. So x4 can be expressed in terms of this. So that means what? Everything is expressed in terms of only 3 variables here. So I can write it as r cube. So 3 is the answer. Let B be the set of all polynomials of degree at most 2. At most 2 means what? Less than or equal to 2 is x square x to the power 0. Okay. Of the following are bases of E. Basis means minimal independent columns. 1x x square. Can I produce any of these columns? Are they dependent? No. This is the basis. Then 1x x square plus 1. Can I produce? No. These are independent. 1 x square x cube. X cube is not in R square. Thus, we are saying 2. So it will not be there in our subspace. So this is not there. X square plus 1. All are independent. The third column can write it as x plus 1. Right? So x is there and then x plus 1. Okay, that means what? They are dependent. And also 1 is not. So this is not the basis of V. Dimension of which of the following is the basis of R? Basis of R means again a minimal subspace. Find out all the independent columns in them. Okay, and then they should belong to R square. So 1 0 0 1. So both are independent. So the following is always a basis. So if I write the vector like this 1 0 0 1, the matrix form. So this will give me independent vectors. Then B 1 1 2 2. So say 1 1 2 2. They are dependent, right? Column 2 is equal to 2 into C1. So this is dependent. So that this cannot be form the basis. Basis means it should only contain independent columns or independent rows. 1, 2, 3, 4. So this is also independent. Okay. Next 0 0 1 0. The basis cannot contain the 0 vector. Wrong. The basis cannot contain 0 vector. The number of vectors in any basis of R power 4 is. So that means what? R4 means we'll have V1, V2, V3, V4. Okay. So that is answer is 4 only. So matrix A is 4 cross 5 with rank 3. then the dimension of its column space is, the dimension of column space itself is the rank definition, so 3. Which of the following sets are linearly independent? So 1 0 0 0 1 0 0 0 1, yes, this is, they are linearly independent. 1 1 1 2 2 2, no, 2 is 1 into 2, 2 into 1 is this, right? So this is not independent. 1 0 1 0 1 1 1 1 0, to check whether it's independent or not. How will you check? By definition you can check, right? So this is C1 V1 plus C2 V2 plus C3 V3 should be equal to 0, and C1 C2 C2 is a trivial solution. C1 is equal to C2 equal to C3 equal to 0. Now, is there any solution possible like this? Yes, only trivial solution is possible. If I add all this to get 0, this 3 has to be 0. There is no other condition. So this is linearly independent. Here only you can check by seeing without applying the definition. Here 1 2 3 2 4 6, they are dependent. Why? If I write this as C1 V1 plus C2 V2, here V2 is equal to 2 V1. So what will happen now? C1 V1 plus C2 C2 into C2 V1 only. So this is C1 plus C2 into V1 plus 2V1. So C1 plus C2 3V1. So V2 is dependent, no? That is the meaning. Next, if V1, V2, V3 is in R cube are linearly dependent, which of the following is always true? Okay. So R cube means 3. The dimension is 3. Now, one vector is 0. No, we cannot say it. One vector can be written as combination of others. Yes, linearly dependent means what? At least one vector can be written as the combination of others. This is true. All vectors are 0. No. Cross product of V1, V2 is 0. No, need not be. Next. Which of the following sets of vectors in R cube are linearly independent? So again you check that this is linearly independent. 1 2 3 2 4 6, it is 2 times this first column. So this is not correct. 1 0 1 0 1 1 1 1 0. If you check here, is it independent? Yes. Then 1 1 1 2 2 2 3 3 3, no, not independent, they are dependent. By seeing only you can tell, or you can apply that independence rule. Next, which of the following sets are linearly dependent? So these two are independent. 1 2 3 2 4 6, this is dependent, right? So into 2, if I multiply into 2 this vector 1, I'll get the vector 2. 1 1 0 0 1 1 1 0 1. Can I add, subtract something? No. 1 minus 0 is 1, 1 minus 1 is 0, but 0 minus 1 is minus 1. If it was minus 1, it would have been dependent. So this is not dependent. Next, 1 0 1 0 1 1. Is it dependent? No, it's not dependent. So only B is the answer. If V1, V2, V3, V4 are vectors in R cube, then there are always independent. They are always independent. They are always dependent. They span R cube. None of the above. So what it means? They cannot be independent because it's R cube and there are 4 vectors. So they have to be dependent. They span R cube. No. Then none of the above is not true. Okay? They do not span. Span means what? It has to produce the complete subspace of your vector. So, but there is V4 here, but it is R cube here, so it cannot span it. The vectors V1, V2, V3 are linearly independent in R cube. So, all are linearly independent. R cube means 3 vectors, all are independent. What is the maximum number of linearly independent vectors that can exist? 3 only, right? So, all are independently, they are saying. Which of the following sets span R cube? Okay. So there should be R cube means there should be 3 vectors. So first eliminate this option because there are only 2. Next. What about A? So they should be linearly independent. This can span it. Then this is also independent, can span it. This is dependent, it cannot span that vector. Okay. Which of the following sets of vector form a basis of R cube? Basis means again minimal column space of A. That is column space of A you have to find. That is minimal number of columns. That is independent columns you have to find. Which are the independent columns here? So this is independent. We'll come to this. C. This is also independent. D. This is dependent. What about B? See, in this kind of examples, be careful. 1, 2, 3, 4, 5, 6, 7, 8, 9. So by looking, you cannot find it. Okay. If you check this determinant, it's a n cross n or 3 cross 3 square matrix. So if I check the determinant of this, I will get it as 0. The determinant of 0, then there are some dependent columns or rows. That is the meaning. You convert this to row echelon form. Okay. And then you will get it as a 0 determinant. You can check it. This is also not the answer. Next. The determinant of the matrix formed by placing the vectors in the columns as a matrix. Straightforward. 1 0 1 0 1 1 1 1 0. So find the determinant of this. 1 into minus 1 minus 0 plus 1 into minus 1. This is minus 2. Minus 2 is the answer. Which of the following vectors is the null space of this? So to find the null space, how will you find this given matrix? A is equal to 1 2 3 4 5 6. To find the null space, so there are 3 unknowns x y z. So this vector they are asking, this should be equal to 0 vector, right? This is the definition of null space. It defines Ax equal to 0. So try to convert into row echelon form. So this will be 1 2 3. So this is my pivot element. Make this, try to make this 0. That is, I will perform R2 is R2 minus 4R1. So this concept already with examples and problems I have explained in the matrices and linear algebra videos. Okay. So please go through it if you don't know how to convert it to REF. So 0, 5 minus 8 is minus 3. And 6 minus 12 is minus 6. X, Y, Z equal to 0. Now, can I further reduce it? Try to make this into upper triangular matrix. Is to divide R2 is R2 by minus 3. This will be 1 2 3 0 1 2 and x y z. Okay. Now x plus 2y plus 3z equal to 0 is one equation. Another is x y plus 2z equal to 0. So y is equal to minus 2z. Now we put z equal to t. This becomes y is equal to minus 2t. So x will be equal to minus 2y minus 3z. So x is minus 4t minus z is t. So this is 4t. So this becomes t. So what is my vector? X is equal to t into x is 1t minus 2, and then I have z as 1. So 1 minus 2, 1 is the answer. And so the following vectors is in the null space. In null space, contains 0 also. Column space doesn't contain 0 vector. Please remember this point. So A, C, both are the answers. The rank of the matrix A is, so convert it into row echelon form and then calculate the rank. So I have given the matrix 1, 2, 3, 2, 4, 6, and then 1, 0, 1. You see, they are same, just swap them. R2, R3. So 1, 2, 3, 1, 0, 1, 2, 4, 6. Now perform R3 is R3 minus 2 R1. So this will be 1, 2, 3, 1, 0, 1, and then 0, 0, 0. Now convert it into row echelon, make this element 0. That is R2 is R2 minus R1. 1, 2, 3, 0, minus 2, minus 2, 0, 0, 0. So this is now in row echelon form. If I want reduce row echelon form, what it says, this element, all the pivots element will be same and 1. So that is R2 is minus R2 by 2. That is 2. 2 by minus R2. So we will get 1, 2, 3, 0, 1, 1, 0, 0, 0. I cannot further reduce this. So there are two linearly independent rows. So rank is equal to 2. Okay. Next, if A is 3 cross 4 matrix and rank of A is equal to 2, the dimension of null space is. So rank nullity theorem says R plus nullity is equal to number of columns. Number of columns is 4. So U is equal to 4 minus 2 is 2. Which of the following sets span the column space of A? Asking for the span, not the column space. So how will you find? The column space of A should contain all the span should contain all the independent columns, and they should be the column of the matrix. So the first columns of A can span the column space. Then 1, 0, 1, 1, 2, 0. So this can also span. Rows cannot span. It will span the row space, not the column space. And D cannot span because it's not the vector here. Next, which of the following are subspaces of R cube? It's x, y, z, 3 dimension. X, y, z, x plus y plus z equal to 0. This implies what? X equal to y equal to z equal to 0. So 0 vector. This is a subspace. True. Next, x greater than 0, y greater than 0, z greater than 0. No, because it cannot contain 0. There is the subspace should always contain a 0 vector. That is the axiom. So it does not contain 0 because all are greater than 0 means it will not get a 0 vector. X, y equal to z, that's the same thing. Then 0 vector, all three. A, C, D. The dimension of nulls for the space of 2 cross 2 symmetric matrices. They are saying 2 cross 2 symmetric matrix. So you think and so we will get the correct answer. Most of them what they say, 4 elements means they will write R4. Matrix A 2 cross 2 is R4 they say. So they say dimension is 4. No. If for a symmetric matrix, if I write 2 cross 2 symmetric matrix, so it will write say A, B. What should be here? It should be here B only because they are symmetric. You cannot different element here. So now how many unique elements are there? A, B, C only. So the dimension is cube. So answer is 3. The cross product UV is 0 if UV is 0 means what? U can be 0, V can be 0. Then U and V are parallel. If U and V are perpendicular, then it's not 0. See, what is this cross product? U into V is equal to UV sin theta. Okay. So when this can be 0, this is 0. This can be 0 when this can be 0, or this can be 0, or this can be 0, right? Sin theta, so this is sin theta is 0 only when theta is equal to 0 degree, right? Theta equal to 90, that means it's a perpendicular. Perpendicular means theta is 1, so it will not be 0. So they are parallel. Thank you for watching. In the next video, we'll start with the orthogonality of the vectors and the matrices. Please like, subscribe, and share.